Hi everyone, welcome back to my channel. Have you ever wondered what makes some neural networks so powerful while others struggle to perform basic tasks? Or why bigger models sometimes fail when they are getting, let's say, more little data? So the answer is this is, let's say, the trainable parameters. But what exactly these parameters? So why do they matter and how we can calculate them in our model, or let's say neural network? If you are asking these questions, you are coming to the right place. Today I will try to dive into this, understanding how to compute, or let's say count number of parameters in your network. So why should we care about, let's see, these parameters? Why we need to calculate these parameters? So defining these parameters is they define the learning capacity. So more parameters mean the model has more flexibility to learn complex patterns from the data. But there is a disadvantage of getting more parameters. It's risk of overfitting or underfitting. So many parameters might cause overfitting, where the model memorizes the training data but fail on the new inputs. This already explained in the previous videos. On the other hand, too few parameters could lead to underfitting. So this model won't be able to capture enough information from your data, even during the training or maybe the validation or testing. So in a short, getting the parameter count right is a critical to building efficient and effective models. But what are these parameters we need to calculate? Or let's see, count. So it's weight and bias. And the weights are the connection between neurons in the adjacent layers. So each connection has its own weight value that model adjusts during the training. For instance, this is our input values, and as I mentioned in several times, the input data won't be changed. Only these connections here. These connections are the weights, and plus the bias. This so for instance, this is a neuron. Each neuron in a layer has associated bias, which help to shift, let's say, the activation function or up or down. And together with weights and bias form the set of trainable parameters that define how the network processes the input data. So now how to calculate these parameters? So as you can see here in our network, this we have input layers. It has only three input parameters, or let's see, input is for instance x1 y1 x1 x2 x3, and this is the hidden layers. I have here in this three hidden layers, and each layer has four nodes, let's see. And for the output layers has three, let's see, outputs. For instance, just like, let's say you are trying to detect the animals, for instance, cat, dog, and maybe horse or any. This is only a sample. Now to calculate these parameters, we have to calculate this parameter from this to this layer, and from this layer to this, and from this to this, and from here to the output layers. So for each layer, we need to calculate how many parameters, and finally we will sum this up to find all these parameters. By the way, this for instance, this is input layer to this layer here, and this layer consider as an input to the next layer, and this consider as an input to this layer. So yeah, so how to calculate this parameter? So I have just simple formula here. It's n plus 1 times m. So n is the input unit. For instance, here I have three inputs. Plus 1 is 4, and multiply by m, where m is the number of output units. So this is output with respect to this, and input with respect to this. Now I have in details calculating the number of parameters in each layer. For instance, here I have 3 input plus 1 multiplied by 4. It will be, for instance, it will be 16. Now this layer here, hidden layer to hidden layer 1 to hidden layer 2, it's 4 plus 1. I mean, with this formula here, 4 plus 1, 5, multiplied by 4, it's 20. And you can see here we have 20. And this one here, from the layer, this layer here to this, is 4 plus 1 multiplied by 4 will be also 20. And here I have 4 plus 1, 5 multiplied by 3, it will be 15. Now all of these, we need to sum all of these up to find number of parameters in our fully connected layer, or called dense layer. So you can see here 16 plus 20 plus 20 plus 15, it's 71 parameters for this simple network. So imagine if you have a big network, how many parameters you will have. You will have to prepare, or let's say trainable parameters, how many trainable parameters. And this is for the dense or fully connected layers. For the convolutional neural network, it's totally different. We will discuss it next video. Thanks for watching, and see you next time.